Hello everyone, this is lecture 21 of Earth Surface Environments, and so now we're going to continue on speaking about some of the main topics that would occur in the exam. And first I want to speak about the lecture series about flooding or the fluvial environment. And so first thing I want to mention is flooding. We think about causes, and I'm just going to list these so that we can know we need to memorize these again. So easy, so simple. We can explain them in one sentence. We can draw if we want, but here I'm just going to put first the causes and then some of the controls. This is what I've been talking about more in details. I was also drawing here on my board. So for causes of flooding, we had basically 5, and those were about snow and ice, melting, so melt. Also, it was failure of these snow and ice dams. And we had then the precipitation type of reasons. So that was rainfall, peak rainfall, with kind of like a seasonal incidence, so that's related to climate, and also the kind of like storm rainfall in not seasonal terms but more like a daily, or so that would be a shorter term kind of rainfall. So storm events, and finally dam failures. And these can be things that are related to things like what we were talking about in case of the mass motions of like rocks. So how dam failures can come together with like rock flows. That is kind of what can be a relationship, but also for the failure of ice dams is what can come together with some of the glacial environments. So whenever we have, for example, the Yohulklab or the Lahar, which is related to, again, an ice mass that melts very quickly, and so the ice itself breaks apart and so on. We had these icy floods, so that I just want to tie here together to another topic. Also for controls, so these are some of the causes, but what else actually will control or shape the kind of pattern of the flood? We said we have these hydrographs in time and the height of the flood or the discharge. So how this will be controlled. Once again, we just want to memorize that here we had 2 main things that we speak about: catchment morphometry which is really about shape, or not even shape but more like the pattern, kind of the way the catchment looks like. So now then I'm just going to put here, it was area, so bigger or smaller. It can be the slope, so that we have a catchment, we have the slope of the catchment area. We also had then was said the kind of the shape the river network, how tributaries are connected, and also there would be a density. So to what extent do we have a dense or more like a thinner network of the rivers? So these are just very quickly to draw. Again, catchment morphometry, and also then we had a kind of control which is about vegetation. So vegetation and catchment morphometry are controls of floods, and in this case then we have one case when we have dense vegetation, and in the other case we don't have. So this is the kind of distinction that will again tell us how fast the flood will be, how the peak of the flood will look like. Now, speaking about floods, we also were talking about how this can be measured, and one way is the POT analysis that we mentioned. So POT, peak, and over a threshold. So POT, peak over threshold. And how we do that again is that we put in order of like event some of our values, statistical data, and then we're going to look at the specific value. So here we have like our axis, and compared to that one we mark out a certain value to which we actually are going to be comparing the frequency of these events and say how many of these will be above this specific threshold. So how many of these events will be distributed in certain parts of the whole data set, or how many at all will be found in a certain part, certain period. That is really about peak over threshold limit. And what we can do, how we do that, just put all the data in order and find the specific threshold data and just count how many and where certain values are going to be located. Where do we find that? That's just the POT analysis once again. What else we will speak about if we are looking at the fluvial environments is not only floods but sediments. And we were talking more in details about things like the lateral and vertical accretion, but this is also going to be related to what kind of like material is being carried in the river. So we had dissolved and kind of suspended material. So if this is the river, I'll just put here a little fishy to show that this is the water. Here we have the river bed, and what we have is dissolved material overall, like in the water everywhere. For example, we can have salt being dissolved. Now this one we won't be able to measure the typical ways that we were talking about, and these will not actually take a role in the landscape formation. So we don't really talk about the dissolved kind of material. Instead, we look at the suspended, which means that there are tiny particles that are carried in the water, and this we can capture with a kind of like a filter, so suspended sediment. But we also said that the bed load will be also very relevant. So how the bottom of the river will be covered by these moving grains. And here then we said that there are different ways that these materials can be moving. One is saltation. So this is kind of like this popping movement of these smaller grains, and the larger particles are going to be pushed and at the same time be pulled by the water, and that will be then the kind of traction. So bed load again will be either saltated or pulled and pushed, and that is traction, the kind of movement and carrying of these materials. And of course then we've seen that there are different methods by which we can measure these. For example, the filter, or we said that for suspended sediment we're going to be able to use these optical technologies, and the Smith-Halley bed load sampler as well, to capture these materials that are moving more on the bottom of the channel. So once again, we'll need to be able to divide what kind of materials are going to be used or deposited, developed in lateral versus the vertical accretion. And we had a specific video about how meandering rivers are going to be developing these fans, and how then certain parts of the river will be then reworking the deposits. It will be lateral accretion, and how vertical accretion would mean that floods were going to be covering the whole area, and mainly the suspended or some smaller particles kind of materials will be deposited overall the area. Speaking about the fluvial environments, we also can think about the geomorphology, or actually the morphological, or the look of the landscape. And so for this reason, then we can think about how like a valley would look like. And we had here different types of like parts of the environment that we can make a distinction of. So there will be a kind of like a valley margin. There's a slope, and there's over here a valley margin. Then what we can find is usually a kind of a terrace. So this flat area over here is a terrace. And I just want to highlight that there are different types of terraces. So we just need to know that these higher grounds usually can be called the terraces. And there would be a kind of flat plain. So over here, this can be covered then by the overbank flood, and obviously we'll have the levees and the channel. So over here we have river channel, these two natural river banks that are developed by the vertical accretion. So these are going to be the levees. And what else we're talking about, here we can have another like terrace or even more terraces, and another valley margin, and another slope. But what else we were talking about is that in certain cases, we'd find these paleo channels. If we just look at this kind of profile or this section, we'll see this one as a paleo channel. And this can be also part of an oxbow lake. Or if there's no lake, no oxbow lake, maybe it's already covered to some extent or filled by sediments in general. So here then we have the main kind of like morphological like parts or phenomena being put on my little drawing that we should be able to know about. We need to be able to explain what levees are, what paleo channels are, what terraces are, make a distinction between the floodplain and the terrace as well. So these are just some of the main points that we should know about. Also, what I want to just very briefly mention here again is how the sediment yield will look like, how it's being formed. And so it's really the controls or the factors sediment yield that we need to mention to some extent. So how much of sediment is carried by the river depends on things like climate, it will also be driven by relief, which is kind of like the slope, we can say, the angle of the slope. It can also be driven by the geology, the rock type, and vegetation, and finally human activities. So what kind of human activities? Well, it can be about agriculture, vegetation, it can be about building cities, urbanization, or whatsoever, deforestation. So altogether, it's very much about climate. We can think about the kind of the slope. Here I put the climate, so the sunshine, also the clouds, and the rainfall. We can also think about, again, the relief. So climate, relief. Also we can think about what kind of material this is. So to what extent is it porous, being able to carry it washed away. Also, then here we can think about the vegetation. So the denser the vegetation, the lower the sediment yield could be, although this is in relationship with the climate as well, so it's not that straightforward. And finally, here we can think about human activities as well. So how humans, you and me, or farmers who produce food for you and me would behave and act as an agent to the landscape. These are just very briefly controls to the sediment yield.